Welcome back to AI.Code.Cast. Today we are tackling bulls and cows. It's a classic coding interview problem, right? You've got a secret code to crack, and you're going to need some really efficient strategies if you want to impress those interviewers.
Oh, absolutely. This one seems simple, but it really makes you think about optimization, which is exactly what interviewers want to see.
So how about we break down the game? Let's say the secret number is 1234, and I guess 1325. How would we figure out the bulls and the cows?
Okay, so bulls first. A bull means you've got the right digit in the right spot. So your guess, 1325, that 1, is a bull because it matches the first digit in the secret number, right? The 1234.
Got it. So we've got one bull. Now what about
Yeah.
the cows?
A cow is a digit that's in the secret number, but you've guessed it in the wrong spot. So in 1325, the 3, the 2, and the 5 are all cows. They're in the secret number, just not lined up correctly.
I see. So you're not just matching digits. You've got to figure out the placement too. Adds a whole nother layer to it.
Exactly. That's where the smart algorithms come in. And today, we're focusing on solutions that use arrays because they're efficient and they're impressive in an interview.
Yeah, yeah. Because I was thinking, like, what if I just kept guessing random numbers? That would take forever, wouldn't it?
That's what we call the brute force approach. You're trying every combination. Technically, it'll work, but it's really inefficient, especially if you have a larger secret number. The possibilities just explode. Your code could run for ages.
Definitely not a good look for an interview. So arrays are the way to go here.
Think of arrays like our toolbox, right? We're going to use them to count how many times each digit shows up. It's called frequency counting, and it's useful for way more than just bulls and cows.
Okay, I'm following. The first solution we have mentions something called secret count and guess count. What are those?
Those are our arrays. We've got secret count, which is keeping track of how often each digit appears in the secret number, and then guess count does the same thing for your guess.
So if the secret number was 11233, secret count would show 2 1s, 1 2, and 1 3, right?
You got it. Now think about how comparing these two arrays could help us find the bulls and cows.
Well, we could find the bulls just by comparing the digits at each position. If they're the same, boom, bull. But the cows, that seems trickier.
You're absolutely right. Bulls are straightforward. But for the cows, those frequency counts and secret count and guess count are key.
I get that the counts are useful, but how do we actually know which digits are cows? I'm kind of stuck there.
Here's a hint. Think about what makes a cow. The digit has to be in the secret number and in the guess, but not in the same position.
So we need to find digits that are in both arrays, secret count, and guess count. But wouldn't we end up counting some cows twice if a digit appears multiple times?
You're getting warmer. That's where a neat little trick comes in. It's not just about the digit being there, it's about the minimum count for that digit between the two arrays.
Minimum count. Why would that matter?
Think of it like matching marbles. Say you have 2 bags, one for the secret number and one for your guess. To make a cow pair, you need 1 marble from each bag, but you're limited by whichever bag has fewer of that color.
Oh, okay, that makes sense. If the secret number has 2 4s, but my guess has 3, only 2 of those 4s could be cows. The minimum count stops us from counting that extra 4, in my guess.
Exactly. It's like the limiting factor in a chemical reaction. You can only create as many molecules as the least abundant ingredient allows.
Wow, never thought about it that way. It's about avoiding unnecessary work, isn't it? We're only focusing on the digits that could actually contribute to the cow count.
You nailed it. And that's the beauty of algorithm design. The best solutions often come from finding these smart constraints that stop us from wasting time and effort.
Welcome back to AI.Code.Cast.
That first solution was really clever, huh? Using those 2 arrays to keep track of everything.
It was pretty neat. But remember, we were talking about arrays like a toolbox. Well, get ready to get even more creative. Yeah, you said there was another solution that was even more concise. The one that uses just one array. Honestly, I'm a little skeptical. How can we track all that information with just one array?
See, that's the beauty of this solution. It's all about how we use the array. This one, it's called numbers. And again, it's size 10 for all our digits, right? But here's the thing. We're going to use the value and the sign, plus or minus, of each element in the array.
Hold on. How can a sign, like plus or minus, help us with bulls and cows?
Okay, think of it this way. A positive value, that means a digit's been seen more in the secret number. A negative value, that means it's been seen more in the guess. Kind of like a tug of war.
I'm trying to picture this. So if a digit shows up twice in the secret number, but only once in my guess, the array element for that digit would be positive.
Exactly. And the opposite, too. If the digit's in my guess 3 times, but only once in the secret number, its element would be negative.
Interesting. So we're kind of like encoding information about how often each digit appears using those plus and minus signs.
Yeah.
But how does that actually help us find the cows?
All right, let's walk through it. We'll start with numbers, all zeros, right? And of course, bulls and cows set to 0, too.
All right. Sounds familiar.
Now, we're going to go through both the secret number and the guess at the same time, just like before. So each digit in the secret, we'll call it S, and each one in the guess, we'll call that G.
So we're comparing the digits step by step, right?
Right. Now, if S and G are the same, well, hey, that's a bull. Easy peasy, increment the bulls counter.
Okay, that part's simple.
Hmm.
But what if S and G are different? I'm guessing this is where the sign trick comes in.
You got it. This is where numbers really shines. 2 things we got to do. First, we increment the value at index S in our array.
So we're basically saying, hey, we've seen is more in the secret number so far.
And then we do the opposite for G. We decrement the value at index G. Remember, tug of war.
Okay, so each digit is pulling on its index in the array, making it positive or negative, depending on where it's showing up more.
Exactly. Now, here's how we spot a cow. Before we go to the next digit, we check the value at indexes in the array. If that value is negative, it means we've seen O number more times in the guess up to this point. So even though S doesn't match G right now, it must have been seen earlier in the guess, which means it's a cow.
Wait, so we're not directly comparing S and G at this point,
Yeah.
but the sign at index tells us if it's already been a cow.
Exactly. Same logic works the other way around for G. If the value at G is positive, we've seen G more in the secret number, so it must have been earlier in the secret, but not at this spot. Another cow.
This is blowing my mind. We're using numbers not just to count, but to keep track of whether a digit has been a cow already. That's so slick.
It is, right. And we're doing it all in one pass through the strings. Once we've seen all the digits, our bulls and cows counters have got the right values.
This single array thing, I'm liking it. Might take a little more brain power at first, but it's elegant and efficient. No wonder interviewers love it.
It really shows that you understand data structures. You can get creative and make things work.
Okay, so I think I'm getting the logic. But I'd love to see how it works in pseudocode. Could you walk me through that?
Absolutely. Let's break it down step by step. First, we need to initialize our numbers array. Remember, it has a size of 10, right? We'll also set our bulls and cows counters to 0, just like before.
Got it. Pretty standard setup so far.
Now we start our loop, going through both the secret number and the guess at the same time. We'll use I as our index to keep track of our position in both strings.
So for each position I, we grab the digit from the secret number, let's call it S, and the digit from the guess, we'll call that G.
Perfect. We have our 2 digits, S and G, representing the current digits we're comparing.
First check's easy, right? If S and G are the same, boom, we found a bull, increment that bull's counter.
You got it. Now for the fun part. If S and G are different, we need to update our numbers array and maybe count a cow.
Okay, time for the plus and minus signs. We take S, and we increment the value at its index in the numbers array.
Right. And for G, we decrement the value at its index in the numbers array.
So now we're using those plus and minus signs to track which string has seen the digit more often.
Exactly. Now remember the tug of war. We check the value at index S. If it's negative, guess is winning. We've seen us more times in the guess, which means ding, 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 we've got a cow.
So we increment the cow's counter.
Yep. And we do the same check for G. Positive value. Secret number wins. We've seen G more times in the secret number. Must have been earlier. Another cow.
So we increment cows again.
Got it. And we keep doing this for every pair of digits in the secret number and the guess. After we've gone through all the digits, the bulls and cows counters will have the right values.
And then we just put together our output string, the bulls, the cows, B format using those values. This whole thing is just, it's so elegant, so efficient. It shows how powerful data structures can be if you use them the right way.
I couldn't agree more. This single array solution, it's a favorite for interviewers because it shows you really understand how to work with data to make your code perform well.
This has been a real eye-opener for me. We saw 2 different ways to solve the bulls and cows problem, both really effective. But I'm curious, beyond just impressing interviewers, where else could we use these techniques?
That's a great question, and it's the perfect lead-in to the last part of our deep dive. You see, these techniques, this frequency counting, this creative array stuff, it's not just for bulls and cows. It pops up all over in algorithms.
Really? You've got me intrigued. What kind of problems are we talking about?
Well, hold on tight because in part 3, we're going to see how these techniques, they can be used to solve all sorts of cool problems, from messing with strings to searching and sorting data.
Welcome back to AI.Code.Cast. We've really dug deep into bulls and cows over the last 2 segments. I gotta say, those array solutions, really impressive stuff.
They're pretty cool, right?
Mhm.
Shows how much you can do with a bit of creativity and the right data structures.
Absolutely. But before we wrap up, you were saying that those techniques, like frequency counting and all that fancy array stuff, they have uses beyond just this problem, right? I'm really curious about that.
You're right, it's not just about bulls and cows, what we've been talking about. These are broader algorithm concepts. It's like learning a new move in martial arts. You can adapt it to different situations.
Ooh, okay. I like that analogy.
hmm
So where else might we see these concepts? What kind of problems?
Well, one area is string manipulation. Like, say you want to know if two words are anagrams. Same letters, different arrangement.
Right, like listen and silent. How would frequency counting work for that?
It's all about comparing the characters, right? If two strings are anagrams, they gotta have the same character frequencies. And guess what? We can use arrays, just like in bulls and cows, to count how often each letter appears.
So instead of digits 0 through 9, we'd have an array for like the whole alphabet. And if the counts match up, boom, anagrams.
Exactly, same idea, different problem.
That's pretty neat. It's not just about memorizing solutions. It's about understanding the concept and being able to adapt it.
Yeah, you got it. That adaptability, that's what makes a good programmer. And these techniques, they pop up in searching and sorting too.
Really? I wouldn't have thought of that. How so?
Imagine you have a massive amount of data. You need to find the items that appear most often. Well, frequency counting is perfect for that, right? And once you know what's most frequent, that helps you design your search or sorting algorithms.
So like, if I know some elements are way more common, I can make my code handle those cases more efficiently.
Precisely. And those array tricks, like using plus and minus signs in that second bulls and cows solution, that kind of thinking can be used in all sorts of data manipulation.
This is really changing how I think about algorithms. It's not just about finding any solution. It's about finding the most elegant, most efficient way to do it. And sometimes that means getting creative, like with those plus and minus signs.
Absolutely. Algorithms are full of these clever tricks, these out-of-the-box solutions. Once you start seeing the patterns, how things connect, it opens up a whole new level of problem solving.
This deep dive has been incredible. We started with this simple bulls and cows game, but we've ended up talking about string manipulation, searching, sorting, who knows what else.
It's been awesome exploring these concepts with you. Hopefully our listeners are feeling inspired, ready to tackle those coding challenges with a fresh perspective and a little bit of experimentation.
I know I am. Thanks for joining us on AI Codecast. Until next time, keep coding and keep those algorithms sharp.